As we've been exploring the idea of algebraic expressions, we've seen that certain expressions are equivalent. That means their values are the same no matter what the variable values are. At first, we saw that we can show that expressions are equivalent by using like terms. Today, we're going to look at another technique that can be used to show that expressions are equivalent. Now, like we've done before, we're going to create a table to explore this idea of expressions which may or may not be equivalent. So in this table we have the expressions x plus 4, 3 times the quantity x plus 4, 3x, and 3x plus 12. We'll evaluate these expressions using the values of x of -3, 1, 5, and 10. Pause the video now and take the time to fill out the table, as well as answer the questions, what do you notice, and what do you wonder? So hopefully you are able to notice an important result from this table, and also hopefully you're able to start thinking about why this result happens. Well, it turns out this is an example of something called the distributive property. This says that multiplying a sum by a value is equivalent to multiplying each term of the sum by that value before adding. If we want to write this algebraically, we're saying that a multiplied by the quantity b plus c is the same as a times b plus a times c. So if we want to multiply b plus c by a, we could just multiply both b and c by a separately first and then add them together. The process of applying the distributive property is called distributing. We can use something called the box method to help us make sure that each term inside the parentheses is multiplied by the value outside the parentheses. We can illustrate this by drawing this box diagram. We have a multiplying the sum b plus c. We can see inside the boxes we get the products a times b and a times c. Those two quantities added together are our new expression. Let's look at some examples of how we distribute in practice. 5 times the quantity x plus 9. So we need to multiply 5 by both x and 9, which gives us 5x and 45. So our expression is equivalent to 5x plus 45. -2 times the quantity y takes 7. So -2 is multiplied by both y and -7, which gives us -2y and positive 14. So the expression is equivalent to -2y plus 14. 7 times the quantity 2n take 3. So 7 is multiplied by both 2n and -3, which gives us the products 14n and -21. So our equivalent expression is 14n take 21. Now in each of our examples so far, the value we've been multiplying by has been a constant, but we can also multiply by a variable as well, as we have here, where we have t multiplying the quantity t plus 7. So t needs to multiply both t and 7, which gives us the products t squared and 7t. So our equivalent expression is t squared plus 7t. We can even distribute when multiplying by both a constant and a variable. So if we have -3p multiplying the quantity q plus 5, we need to multiply -3p by both q and 5, which gives us the products -3pq and -15p. Our resulting expression is -3pq take 15p. If we have 2u times the quantity 3u take 5, we need to multiply 2u by both 3u and -5. So 2u times 3u is 6u squared, and 2u times -5 is -10u. If you're finding these a little tricky, what you need to do is think about the constants and the variables separately. So in the first product here, we can just think of doing the 2 and the 3, our constants, and get 6. And then we can think about our variables, which are u and u. And we can write u times u as u squared. Our final distributed expression is 6u squared, take 10u. Now so far, all of our expressions have had a sum with 2 terms, but this still works even if we have 3 or even more terms. So let's look at negative 4 times the quantity 3a take 5b take 9. So negative 4 needs to multiply each of those terms. So multiplying 3a gives us negative 12a, multiplying negative 5b gives us 20b, and multiplying negative 9 gives us positive 36. So our final expression is negative 12a plus 20b plus 36. For our final example, we have 2x times the quantity x plus 3y take 5. So 2x needs to multiply, firstly x, which gives us 2x squared, 3y, which gives us 6xy, and negative 5, which gives us negative 10x. So our final expression is 2x squared plus 6xy take 10x.